Exercise 5C delves more into some of the features of the calculation for the coefficients in a binomial expansion. So you've been using NC0 or NC1, and up until now you've relied on your calculator to calculate those for you. Because of the nature of some of the questions that you will see towards the end of this exercise, which are the common HSC style questions, it's not so much evaluating these coefficients rather than comparing them that is the skill that is required. So we have to have a good understanding of this calculation. So you might have seen back in a previous exercise that I defined NCR as n factorial over n minus r factorial times r factorial. So what we actually do now in this exercise is to focus on what this factorial notation actually is and have a look at some variations of the ways to write a factorial. So by definition, the factorial, say and I think an example, a numerical example is probably the easiest to understand. If you were given 3 factorial, it actually means 3 times 2 times 1. So we start with the number, we multiply by the whole numbers 1 less than the previous number all the way down to 1. So when you see n factorial, we start with n, we're still going to multiply by whole numbers until decreasing by 1 until we get down to 1. So the way that we write 1 less than n is n minus 1, and 1 less than that is n minus 2, and this would go times n minus 3, blah, 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 down to 2 times 1. However, if I was thinking about n minus 1 times n minus 2, means I'm starting with n minus 1. If I started here, I could then write this section in itself as a factorial, which is demonstrated in the next line. So another way to write n factorial would be n times n minus 1 factorial. So, for example, 6 factorial could be written as 6 times 5 factorial. There's nothing special about choosing the factorial to be the second number in the expansion. You could also write 6 factorial is equal to 6 times 5 times 4 factorial. Now, like I said, it's just these different ways of writing and thinking about factorial aspect of the binomial coefficients that will be what you're looking at in questions later on. Okay, let's have a look at some examples. So if we're simplifying n plus 1 over n minus 1, so what we see here is a fraction. We're simplifying a fraction. We are still going to perform similar processes for simplifying an algebraic fractions as we always have. So nothing's changing there. We know that if we want to simplify an algebraic fraction, then we can't do any simplifying with addition and subtraction signs, let alone the complication in this case of a factorial sign. we know that we need to have terms being multiplied in our numerator and denominator so that we can do some cancelling. So that's what we're going to do. Rather than writing n plus 1 factorial, we're going to think about what that is, which in turn then conveniently introduces some multiplication signs. So we know it'll be n plus 1 times 1 less than it is n times 1 less than that is n minus 1, which you can probably see we could stop there, and in fact we should stop there. However, I'll just keep going. N minus 2 times n minus 3 times ... times 2 times 1. All over n minus 1 factorial. Now, strategically, I'm going to start over here with it, just so to make the point. N minus 1 factorial is n minus 1 times n minus 2 times n minus 3 times ... all the way down to 2 minus 1. Now you can see we've set this up such that our numerator and denominator now contain terms separated by multiplication signs, which means that we can fully cancel all of this and fully cancel all of that, and we're simply left with n plus 1 times n, which you're probably going to write as n times n plus 1. I don't know, it's not necessary, wouldn't be incorrect to write it as n squared plus n. Yeah, and you could do that. Like any one of those three is going to be, answers is going to be fine. So I just want to say that we could have simplified some of this working to just n plus 1 times n minus 1 factorial as the numerator over, and we really wouldn't need to do anything with the denominator, and knowing that this term and this term are identical, we can cancel them out. We've introduced the terms being multiplied into the numerator, we've got a single term in the denominator, and you'll get the same answer. So we're really just becoming familiar with writing out expansions for factorials. Okay, this next question, a little bit different, although the instruction is still simplify, but it's different in that we've got the addition of terms, just straight out addition of terms. Now, how do we simplify the addition of terms? Well, anything involving pronumerals, we're usually looking for like terms. We haven't got, well, I suppose contained within the bracket is an n and in the bracket is an n. We know these are indefinite, infinite expansions. It's not really looking like we're probably going to be able to find some identical terms. So on the other hand, another method that we've previously seen in simplifying expressions with an addition sign is to factorize. So that's what we would do in this case. We're going to factorize these. So in order to get an understanding of, and it simply requires taking out a common factor, then we would write n plus 1 factorial is n plus 1 times n, times n, and I'm going to stop, and it's probably pretty obvious why, at n minus 1 factorial plus n minus 1 factorial. Looking at those two terms, you can see there is a common factor of n minus 1 factorial. Taking it out of the first term, we've got n times n plus 1 plus 1. If I take n minus 1 out of here, I'm left with just 1. So it simplifies to n minus 1 factorial. N times n is n squared. N plus 1 is n plus 1. And we stop there. With example 3, you can see we're simplifying again. When we look at that, we see we've got some fractions, yes, and within the fraction there's this added complication of it being a factorial. But more importantly, it's a subtraction of fractions. So again, we use rules that we've previously learnt about simplifying algebraic fractions, the subtraction of algebraic fractions, which would require a common denominator. Let's have a look at what the denominators are. N factorial is n times n minus 1 times n minus 2. I'm just going to put dot times dot dot dot. And this numerator is 1 over n plus 1 times n times n minus 1 times n minus 2 times dot dot dot. Now, you know we want a common denominator. So this is already a factor of what we've got there. So we know that the lowest common multiple of these two is the second one, which is n plus 1 factorial. So to get our n plus 1 introduced into here, we've got to multiply by n plus 1 over n plus 1. That now gives me the appropriate numerator and the appropriate denominator and common denominator. Add them together, we'll have n plus 1 minus 1 and simplifies to n over n plus 1.